A challenge in the current transition of our energy system is the use and storing of electricity. This is water, and we can use electrochemistry to store electrical energy, or electrons, into chemical bonds and make useful chemicals. In this reaction, that's oxygen, and more specifically hydrogen. Making hydrogen is actually easy, and you can just do it at home, but it's not always efficient. Unfortunately, the most efficient materials, such as platinum or iridium, are rare and expensive. While we would like to have other efficient materials that are cheaper, we don't fully understand what makes for efficient electrochemistry. So what is electrochemistry? In principle, we have a solid and a liquid, and we need to get electrons across this boundary. We already know that the efficiency is determined at the level of single atoms, and we can use a microscope to see these surfaces by using a very sharp needle that scans over the surface, very much like a record player. However, we are now realizing that the liquid is also important. An intuitive explanation is that water molecules near the surface can strongly order, or be a bit more random. In this case, electrons have a hard time entering into the rigid structure, but if the water is very loose, electrons can easily cross the boundary, giving high efficiencies. We therefore need some chaos in the liquid, but this is something that our microscope could not see. We want to solve this issue making use of the same mechanism. In this case, we pull our sharp needle from the surface and measure how much force that requires. This force also depends on the structure of the liquid. If the liquid is chaotic, we measure a small force. If the liquid is rigid, we measure a large force. In this way, we will measure the atomic structure of the solid and the liquid simultaneously. We then get the full picture of the electrochemical process, so that this will help us to understand and improve this.